So in this video, we're going to show a couple of things for the Series-37XE. Number one, we're going to show the power on sequence for the system and just how that's accomplished and what an operator would do to power up the entire system. And then the second thing we're going to do is we're going to take a look at the firmware operator commands that are available on the hardware that are used to verify correct configuration and operation of the CPU here and the different peripherals that are connected to the system. So again, this is a fairly typical configuration for an XE system. And what we're going to do, or what I do usually, is especially on a system with a lot of peripherals like this, is I always power up the peripherals first so that they're spun up and they've finished their self-test before I even power on the CPU. So what I'm going to do is just start with the disk drives, these two disk drives, and we'll see the lights, indicator lights come on. They're flashing because it's running some self-tests and verifying correct operation. And when I press power here, we'll see some indicator lights come on for the cartridge tape drive, the disk array here. We only have we have a power supply, but we only have one spindle in this disk array. So what we'll see is this green light here is for the disk spindle. This is the power supply controller. There's two other lights in here, so if we had other additional spindles, those lights would be lit up. And then on the 7937, it's starting to come up. The other peripherals, I'm going to bring the 7980 tape drive, power that up, and the line printer. Okay, so it looks like these disk drives are up. These drives are up. The 7980 is up, and so is the line printer. So let me clear the console here. And the next thing I'm going to do is power up the CPU. And right now it's showing this amber light here is that it has AC power. As soon as I turn the switch here with the key, then we'll see the LED indicator here is going to show us what power on self-test, or what POS is doing, and then we'll also see the DC light come on here. We may see this I/O light blink if it does any I/O when we're running some of the diagnostics, but probably not during the self-test. And again, the key here is just something that's removable that an operator could use to lock down the system. So what we're going to do is put that back in here. And we're going to switch from 0 to 1. Okay, the lights come on. So it ran a couple of CPU diagnostics really quick. It's on a post B, which is a memory test. And that actually takes a while. We only have 4 megabytes of memory, but again, this is a early 1980s low-cost minicomputer technology, so not super fast, even though it's only 4 megabytes of memory. But after a few minutes, we'll see this flash, a couple of different tests, and then on the console, we'll see a prompt come up. It'll print out that there's no microcode, and like some tests that finish the cache tests and so forth, and then it'll prompt us, and at that point we can enter firmware commands and so forth. So one thing that I have not done as kind of a test or an example of how we can use some of these firmware commands is I did not turn on the 7974 tape drive. So when the console comes up and we run a firmware command called IO map, which goes out and looks at the IO system and tells us all the peripherals that are connected, we're not going to see anything connected on HP IB address 2. We're going to see 0, 1, We're not going to see 2. We're going to see 3, 4, 5, 6, which is the line printer, and 7, which is the tape drive. And then, once we notice that that isn't powered on, we'll turn on that 7974 tape drive, which is the big one in the cabinet. And then after that power goes through its post and powers up, we'll be able to see that. Okay, so what we're waiting for now is just the console prompt to come up, and then we can start looking at the firmware commands. Okay, so we see the power on output from the firmware, and it's telling us it's finished the power on self-test, cache memory, tests have passed. It's going to tell us how many megabytes of memory we have. We have 4 megabytes. And then it's going to tell us what I/O channels it sees on the system. We're in normal mode, which means this key switch here is in position 1, which is normal. That's the production, mode for it to be in. If we were to put it in 2 or 3, 2 locks out any console commands. So what an operator could do is switch this to 2 and take the key out. Then the system's locked down. Usually these systems would be in a remote office or on a factory floor or someplace like that, and there would not be a resident operator or system administrator around to take care of the system, or the system might not even be locked in a computer room. Actually, these usually were not. So what an operator or administrator could do is just lock the system down somewhat, not totally, because you could still power off peripherals and so forth. But they could remove the keys so they could control what kinds of commands could be done from the console. But we're going to put it back in mode 1 for right now. Actually, let's move it to position 2 and just look and see what happens on the console. So if we just hit return, oh, okay, so we're going to see that it actually changed to what's called local mode from normal, so it's in position 2. We're going to put it back in position 1 because we want to be able to do all the firmware commands. Okay, so the first thing we can do is just list out, do a help command at the console, and there's no software running on the system right now. This is just talking to the firmware that's resident in the CPU. And just to make a distinction, firmware is rudimentary software which is running on the CPU. It's not microcode. So microcode for the 3000 is different in that microcode is actually used in the gate array to implement the instruction set architecture, the stack-based architecture. So there is some rudimentary support in there, but firmware is not microcode and vice versa. So this firmware set of commands here does essentially 3 things. One, there's a panel subsystem which can be used to kind of poke around in the hardware, the CPU hardware, and look at memory and so forth. And that's mainly used if you're doing system software development. So if we look at the panel command, we see, sorry that scrolled by really fast, but there's some commands like the trace command is a good one. Trace, if we do trace, it's going to show it, it's going to walk the stack and show us all the markers that are on the stack. So if we see here that it's looking at the ICS, which is the interrupt control stack, and that's the stack object that system software runs on. So we're in when we're in supervisor mode on the CPU, the software is going to be running on the ICS, or the interrupt control stack, and then it's going to just trace through the stack markers there, and then give us another prompt. So we can do things like look at memory. We can peek and poke around I/O devices and set breakpoints and so forth. So again, this is really used for system software development or CPU troubleshooting, that kind of thing. So let's get out of that subsystem, go back to the main firmware command, And the other set of commands we want to look at are test. So test is a subsystem that has a set of utilities and commands that we can use to look at the hardware configuration and validate that correct configuration of the hardware and run some rudimentary tests. Like, for example, we can do the power on test of memory, CPU test. So let's just do that real quick. So if we run the CPU test, what we should see is that CPU test indicator is going to come up here. Okay, so if we look at the console, we see it's cycling through the 7-segment display there and so forth. So, okay, here's the address, here's the data, and then it's going to look at the LED display. I don't want to run the memory test because that takes a while. Let's see what else. Let's run a channel test on channel 4. Okay, so it's telling us we can't loop, but it's still going to run the channel test. Okay, so that test passed. Actually, let's do the CPU test real quick and try a little experiment. So if we do CPU, let's say we want to, there's a count parameter on the CPU and some of the other tests. Let's tell it to run it, and that count parameter says how many times to run that test. So let's tell it, the default is 1, but let's tell it 2. Let's say CPU 2, so it's going to run the CPU test twice. Oh, okay, so it's saying we can't run that test in normal mode. We can't specify count in normal mode. It's going to go ahead and do it. See, we saw the LED indicator, and it passed that test. But let's put it in mode 2 here and see if we can specify a count. So CPU 2 again. Okay, now it's going to run that twice. So here's the first time through, and it's incrementing the LED indicator. Boom, went through F. Okay, now it's cycling. This is the second time through. D, E, F. Okay, done. That's because we had it here. So that's why you want to leave, or operator would leave this in normal mode, take the key out, and so forth. So people couldn't fool around, supposedly. Some not rigorous security, but some, I think, not so much security, but just keeping people from fooling with the system. Okay, CPU test. So the most useful, or one of the most useful commands, firmware commands, is IOMap. And what IOMap does for us is it's going to go out to all the I/O device, or the peripheral devices that are configured on high-speed devices, so on PICs, or peripheral interface controllers, and tell us what's connected to those. And also give us some information about I/O configuration that's stored in non-volatile memory. So let's run that and see what it tells us. So, what this is saying is, the first thing it's saying is 4 megabytes of memory. The load and start parameters. So load tells the system, this is the I/O device, the address of the I/O device I'm going to use to load microcode and system software from tape. So I'm going to load microcode and system software from channel 4 device 3, and its start dump is the hardware address that I will use to do a start from disk for loading microcode and system software. So that's going to be on HPID device 1. And then what we see here is we see all the peripheral devices. If it knows what the name is, it'll print it out here. If not, it'll just say it's some generic device. So we have 0 and 1. So that's going to correspond to HPIB address 0 and 1 here. We don't have a 2. 3, 4, 5. There's no 6 or 7. So supposedly we powered on all the peripherals, but we didn't. Remember earlier I said the 7974 tape drive we did not have powered on. So what we're going to do is power that on. I'm going to do that right now. Let me just show you. So we're going to power the tape drive on, and we'll see it go through its self-test here. And it's running. It's going to exercise the lights, doing the display. So this actually takes a few minutes for this guy to get started up. And while it's doing that, let's go right back over here. And let's see if it has powered up yet. Or if we see it. Okay, so now we see on device 2, 7974 mag tape unit. So we still don't have a device 6, and device 6 is the printer. So maybe if I put the printer online, we'll see it. So I put the printer online, IOMAP. No, and I see a device 7, but it's device 7, it's saying it's a generic peripheral device, and I think that should be saying 7980 tape drive. So there's some issue here. So what the issue is that the line printer is configured to be HPIB at HPIB address 7, and the tape drive, I'm going to show you. This tape drive is configured to be at HPIB device address 7. The line printer says 6, but you know what we're going to do? We're going to go look at the configuration for that. So let's see. So looking at, whoops, hang on a second. First we have to take it offline. So there's light right here. So online, offline. Offline, and we want to config, so we're going to hit the config button here. And I'm going to cycle through config 1, 2, 3, 4. Okay, 20 is the address. So if we look at the address, let's see if I do this. Whoop. Okay. So this is configured as HPIB address 7. So actually we want it to be 6. So we're going to hit this key here. It's going to be 6. We'll press enter. Okay. So now let's do IO map and see what's different. Interesting. Okay, let's put this guy back. So now what we see is, you see as device 6, you see the line printer, and this guy is a 2563 line printer, and you see the correct name or model number for the tape drive. So 7980 magnetic tape drive. So that's a really useful command for an operator, anyone, a CE, an SE, and where an SE was a systems engineer, kind of the software counterpart for a CE, who was a hardware guy. This is a really useful command to just confirm that everything was configured correctly and online and so forth. So if we look at some of the other test commands, one other last thing on the IOMAP command. So remember that there's some peripheral devices, again, remember This is firmware which was shipped with this CPU, let's say in 1982 or 83, something like that. These two guys here, which are listed as kind of generic HPIB devices, if they came out later, this CPU is not going to know about these guys. These guys over here, especially 7937, it will know about because they either came out at the same time, so the information about this could be programmed in here. But if the device came out later, it can still be supported on HPI because it's HPIB. But the CPU firmware may not recognize it because it can't predict the future. That kind of thing. Okay, let's see if there's any other commands we might want to look at. So one last command we can do, or that we'll do, is power on. So that's going to do the power on self-test. Memory test is going to take a while. So what we'll do is, after the self-test is over, we will go back to the main firmware menu or command prompt and just look at a couple of commands, the load command or the start command. And the load command, again, is used for either loading from a cartridge tape drive or real tape drive. And in the next video, what we're going to do is look at loading some software off a real tape onto the system. And this is going to be the diagnostic utility subsystem. And that's a tape with a bunch of utilities and hardware diagnostics on it that provide a lot more extensive testing than the tests that are here in the firmware on this system. Okay, still looking at memory. Unfortunately, there's not a Control-C or anything to abort that. So we just have to wait, and wait, and wait. A lot of times when a new system was being installed for the first time or updated, that would be done at night after everyone had gone home, like after 5 o'clock or after midnight or whatever. So as not to disrupt any online processing. Although it could interrupt batch processing that was going on offline. Or, excuse me, not offline, quote, after hours. Okay, so we're back. It's finished the self-test. So what we're going to do is exit out of that. And look here. And so the other commands that we're going to use with the dust tape are, we're going to use the load command to load from channel 4, device 7, which is a 7980 tape drive. And we're going to use that to load microcode and the diagnostic utility subsystem. Just real quick, cold start was to load from tape, similar to load, but assuming nothing is on the cold start will load from disk. Cool start will load from disk. Warm start will load from disk. Warm start preserves spool files and other temporary files. There's some redundant commands in here like tape and load, kind of do the same thing. Speed, you can use to change the speed of the system console. New and load kind of do the same thing, but the commands that most users or operators would use would be load and warm start would be what most people would use. Some of these commands, like reload, would just reload the operating system but preserve the I/O configuration. So if you're doing an update, you can do update here. So just these commands would replace some information on the system and preserve others, or just assume that nothing was there and was brand new. So the next thing we'll do is look at loading a dust tape on the system and running some commands for that.